This is problem 6 from the sheet. For this one, you're going to use momentum is mv. We're also going to use the idea that momentum before equals momentum after, so mv plus mv. You also, but not on the mock test, but on the test itself, you're going to use force times time as mass change in velocity, because you can see, right? Basic momentum impulse, person jumping from a cart. So it's got 2 parts. The last part is the part that we're going to do, and it's the hardest part. So here's this cart. Here's Bob, right? He's driving. He's going along. He is 65 kilograms. This is 37 kilograms. All of it's going 3.5 meters per second. He jumps off in the second picture. We see him, and he has jumped off this way. He's going this way at 2.1 meters per second to the left. And the cart, what is the cart's velocity? So the cart is apparently, here's the ground. Right, he's up in the air like that, right? And the cart is apparently going this way with some velocity, and that's what we want to find, right? So we go m times v, right, is m times v plus m times v. So 65 plus 37 times 3.5. And then what do we do with him going to the left? What's the trick there? Negative, there we go. So he's 65 times negative 2.1. And then the cart is 37 times the v that we don't know, right? Yeah? That's how we did the human 3-stage rocket, right? We jumped off the back and the cart went faster forward, right? So 65 plus 37 in parentheses times 3.5. And then aren't I going to add this to both sides? So I'm just going to do that right now. So I'm going to say plus 65 times 2.1 is 493.5. And then we just divide by 37, right? We get 13.3. That's cool. And then it says the same exact problem, right? Only it says now he's going to jump off. Oh, do you have questions about that part? Now he's going to jump off and give the cart a velocity of, instead of 13.3, it's going to have a velocity of 18.1, right? So this guy is 18.1 positive, right? And now his velocity is, we don't know, right? That's like the same problem, isn't it? Right? Essentially, it's just that we don't know his, right? So we set it up the same way. The left side's the same, but I'm just going to do a different right side now. So him in the cart moving this fast equals him going some unknown velocity, right? Plus the cart going, what is it, 37 times 18.1. How did I know this was positive? To the right, yeah, there we go. Okay, so this becomes this, then I'm going to subtract this to get everything on this side, right? So second entry, there is 65 plus 37 in parentheses times 3.5, and then I'm going to take this, subtract it from both sides. So minus 37 times 18.1. And I get negative 312.7 equals 65 times v. Why is it negative? Divide by 65. It's negative because he's got to jump off. He's got to go to the left, doesn't he? Yeah, so his velocity is negative 4.81. Yeah? But just be careful. Notice how the problem said right and left. The negative is just our own imposition on that. You need to say, to tell me that it's to the left. Right? And then if you say negative to the left, it's like, well, what are you really saying? Are you not going to go? I don't know. Do you deny confirming not wanting to not go? I don't know. Someone asks you a question, that's a fun thing you can do. You want to go to the movie? Yes. No. Yes. No. Yes. Yes. No. You're driving crazy. They might not be your friend after that.